We're going to talk now about what science actually is. When I say that it took humans thousands of years to develop this process, what process am I talking about? So I'm just going to kind of walk you through how scientists approach knowledge and the universe. So the first step is observation. Observation just means to see something, to notice something. So I'm going to write, I noticed that good scientists are always looking around the world and paying attention to what they see. And that leads them to ask questions. I'm going to write, I wonder if ... Scientists want to know why things happen, how they happen, when they happen. These are all question words. Now, scientists tend to be very intelligent people, and so they often come up with a hypothesis, which is an educated guess. It's what you think the answer is. So I think that ... This is where most philosophers stopped the process. They would come up with amazing hypotheses that were very complex and very intelligent, but they didn't complete the rest of the scientific process. And that was what made philosophy weak. So the scientific revolution is what happens next. First, you design an experiment. You have to come up with a way to test your hypothesis. So test my hypothesis. Most experiments will have at least two variables. There's what we call the independent variable and the dependent variable. And we will talk more about what those are in a later video. The independent variable is what the scientist is changing on purpose, and the dependent variable is what they are watching and measuring. As they perform the experiment, scientists have to write down their results. This is called data. Data just means information. There are two kinds of data. There's quantitative, which is spelled with a T. Quantitative just means it can be counted, it can be numbered. So quantitative data is anything that you can write as a number. Your height, your age, your weight, these are all quantitative. The second kind of data is qualitative. It is spelled with an L. Qualitative is just a description. It can't be given a number. So the color of your eyes, how soft the fur of a cat is. These are qualitative. We don't use numbers. Scientists collect both kinds of data, but they prefer quantitative because numbers are easier to analyze and find patterns. And so if it's possible, a scientist will try to take a qualitative feature and come up with a number system that allows them to actually measure it using numbers. For example, it is possible to actually measure color using numbers, but it is complicated. After scientists collect the data, they then have to analyze it. Analyzing it just means that they look for patterns. So I'm going to write the word patterns. This often requires graphs. And the end product is often an equation. Equations are just math expressions that describe patterns using math formulas. At the end of an experiment, the conclusion goes back to the hypothesis. So the conclusion really answers the question, was I right? So you look at what your hypothesis was, and then you decide, yes, I was right. I have data that supports my beliefs. Or sometimes you discover that no, you were wrong and your data contradicts what you thought. The evaluation, instead of asking, was I right, it asked the question, do I trust my results? Sometimes you get results that are so strange or unexpected that it might mean you did something wrong. Or sometimes you know that something went wrong in the lab that may have contaminated your data. It's okay to acknowledge that. Good scientists have to say, you know what? I don't trust my results. Something went wrong. I need to do the experiment again. And finally, one of the most important things with science is even after you have finished this scientific process, it is super important that you keep an open mind. What that means is, if new data is collected in the future, if new experiments are performed that don't agree with your results, you have to be willing to re-examine your conclusion and acknowledge that maybe you weren't completely right. A good scientist is always willing to say, I was wrong, if new data is presented to them. So I hope that as students, you are also willing to keep an open mind and change some of your beliefs and ideas as you're presented with new information.